Welcome to my short overview of in-silico patient-specific mitral valve model for transcatheter edge-to-edge repair. On the left side of the heart, between the left atrium and the left ventricle, we have the mitral valve. During systole, with ejection of the blood through the aortic valve, the mitral valve needs to be tightly closed to avoid backflow in the left atrium. However, it can happen that the mitral valve is not closing properly, allowing a jet back into the left atrium. This is called mitral regurgitation and is the second most common valve disease after aortic stenosis. To address this complex coupled behavior of blood flow and valve tissue, we use an in-house fluid structure interaction solver. The fluid solver used for the blood is a 6 spatial ordered direct numerical solver with a structured staggered grid. The structure solver is based on the Moose library with a hyperelastic Holz-Apfelgasser Ottgen material model for the valve. To combine and couple the fluid and structure interaction, we rely on a 2D projection transfer to find intersection and apply the according velocities and forces to each other. Here you see in the middle a mitral valve attached to a plane with a left ventricle on the bottom and the left atrium on the top part. There is another plane at the top to mimic the pulmonary vein inflow from all four corners. The fluid domain is periodic in every direction and measures around 6 cm by 4 cm by 10 cm. We apply a pressure force at the top of the domain to accelerate the flow through the pulmonary vein holes in the top corners and then through the mitral valve. So we are simulating the diastole with the filling of the left ventricle, starting with an open valve. At the tip of the mitral valve, you see a D-shaped vortex that is formed and detaching. This is followed by more complex vortical structure which are breaking down the initial D-shaped vortex. Additionally, you see a dorado cardiac flow in the left atrium before the mitral valve. I'm looking forward to see you at the poster session A2 on the 8th of July in the foyer E North.